Day two. There are two exciting things today. First is there was a Ask Me Anything session from A4VC. Uh, so we went to San Francisco, and then there's founders from Podkey or Podchi. It's PODQI. Not sure how to read that. Anyways, they gave a talk and talk about their stories. It's quite inspiring. I also met a lot of other founders there. It's quite a fun. And second exciting thing today is about this GitHub. So it's my first time to get my hands dirty on the robotics application. And this ACT is like an year-old uh, method from this paper. Um, and this paper, they presented a hardware setup called Aloha, as well as ACT, it's a software, action chunking with transformers. We're not gonna go into details about like what they're doing. Then basically, this ACT is a method to train these robot arms. Basically, it's an imitation learning method. So today, what I did was go through this GitHub. They have this installation. So I made a Docker file for this installation of GPU server, set up the environment, and make sure all these commands running properly. So we did training and testing in the simulation environment. So to collect the training data, you need to run this record sim episodes. And then how it looks like is this. You see there are two robots and one red cube in this virtual environment. And the task is to grab this red cube using the right arm and then pass it to the left arm. And then you collect 50 demonstrations of that. And then that's going to be a training data for the imitation learning. And then use that data to train. This is the train code, train command. And then based on this, you will get a certain model in your checkpoint folder, and then you're gonna run the evaluation by adding this flag. So I make sure it's working on our server, and I also try to understand what's going on inside the code. For example, like this training data. So it's just the two random robot arms there, and then there's a cube, red cube there. So how do you actually automatically generate the training data for this task? That's a huge question for me. And turns out it's actually very simple. In this case, let's see, record sim episodes. Um, so in this file, they have this make eSIM environment. So it looks like these parties are creating the environment where there are table, and then you place a red cube in a random location and then set the initial location of both arms. And then you look at the policy. And this policy is based on this policy class. And then this policy class is defined per task, which means for each task, you have predefined way of determining the policy. And then the task I picked was the pick and transfer policy. And this pick and transfer policy is from scripted policy file. So we go there. And then I found here pick and transfer policy. And it turns out the way to create this training data is quite easy. Like they generate the trajectory here, and then you first start with the initialized left arm, right arm, and then since you are the one who create the simulation environment, you already know where the box is. So the XYZ is the box location, box create QUAT is a quaternion, the rotation of the box. The thing is this box quaternion is never used in this generation trajectory, which means when you generate a trajectory, you don't care about the box orientation, which is quite unrealistic. Then I think author just wanted to simplify things here. And then you have the gripper orientation, and then you already predefine where those left arm and the right arm will meet in the middle. So that's the meet XYZ. And then when you meet, the left arm will have this quaternion. So everything is like hard-coded here. And then this is a left arm trajectory and right arm trajectory. And left arm and right arm have different tasks. So their trajectory is also scripted in different way. So left arm first is like at the t equals 0, you start with the initial location and initial orientation. The gripper is closed. And then you need to go to meeting location, right? Meet XYZ. So at the timestamp of 100, and then you have certain offset. So it asks the robot arm to move close to the meeting XYZ. And at this timestamp, you see the offset is smaller than before. So you move closer to the meeting position. And then at this timestamp, the gripper, the location is the same, but then gripper is changed from 1 to 0, which means gripper was open before. And at this timestamp, the gripper is closed, which means it assumes that the object, the red cube is inside the gripper. So it's going to grab it. Something like that. It's very simple and kind of stupid way of just tell the machine to how to move. It's because in this case, the left arm has no idea of the status of the cube or the status of the right arm. Right? It's just the most stupid way of hard coding the left arm. And right arm is simple. It's from the initial location, and then it go near the box location, and then go down to grab the box, and then you change the gripper from 1 to 0, which means you assume that you grab the box, and then you're gonna move to the meeting location after that. And then at some point you release the gripper, open the gripper, assuming that the left hand already got the object. So this is again, this right arm has no idea where the left arm is, has no idea if I already picked the object or not. It's just one way of generating simple trajectories. And when you actually generate the trajectory and make the actions of that, you actually inject the noise so that every episode you have a somewhat different motions of the left arm and right arm. So that's how they create the scripted policy. It's going to be very different from real policy. But anyways, this code works. And then I was able to create 50 different episodes that looks like these, but then every time the red cube location is different. And then robot try to do that and then see if it's success or fail. Right? So actually, this command runs in maybe 1 or 2 hours. It's quite fast to train these 50 episodes in this simulation environment. That's actually quite encouraging for us. For now, we don't have huge compute. Looks like we can train simple model in just a few hours. And this is awesome. Most function that you rarely see, I think, is because the task is so simple and it's in simulation environment, so you get a very beautiful train and validation loss. And actually, the video I show you here is test result. So it's an unseen location of the red cube. And in the evaluation code, it says I mean, the evaluation command line output, it says is successful, but it was not successful, obviously. So I guess there's some bug in the evaluation code. And it actually success like maybe half of the time. See, this is another failure case. And then at this time, it's kind of successful. Just like that. Okay. So it's quite exciting because first I found a way to run simulation in a simulation environment using two robot arms. It's just pick and place and then transfer the object. And I found a way to make a script of how to create this simulated trajectory. And then I found a way to train and evaluate it. So I think that's the basic ingredients. And then later, maybe tomorrow, we can focus on how to create uh, this training data for our use case. Right? So I think that's going to be another exciting uh, task. Yeah, I think that's it for today.